Guys, is my voice audible to you guys? I hope everyone is able to hear my voice now. Yes, cool. So, yeah, in today's class, we'll be discussing about the capacitors, few problems which we left out. So that we'll be completing the capacitors problems. Then we'll be starting with the next chapter, that is the current electricity. So we'll be starting with the basics of current electricity and also trying to complete as much as possible, say up to at least we have to complete mobility of electrons. So yes, so we have to go a bit faster, guys. So we have to rush up a bit because yeah, there was a notice few days ago. There was a newsletter which was arrived and it said maybe your exam, I mean the JEE mains exam would happen somewhere around February. So if that's not confirmed yet, that was just a rumor, I guess. But if that's happening, then we have to be a bit rush, be in a bit urgent, or should be in a way that before Jan or before at least your second reward starts, we have to complete our syllabus, right? So we'll be bit fast in completing syllabus. Please help us to do that. So please call all your friends to the class so that we can start the class and you could join. So hi YouTubers, good evening. So what here? So currently two are watching. So I guess is there any tests for you guys scheduled? I guess there might be some tests for you guys scheduled. Is it? So hi Ayur Prasad, Bhargav, Priyanka. Hi, good evening, YouTubers. Cool. So yeah, we have to complete the syllabus as soon as possible. Okay, so we have for which we will be going up faster a bit. Okay, please help me do that. Okay, guys, cool. Thank you. Your support is very much necessary in this case, guys. Everyone, please take your technical check. Everyone who joined now, please take your technical check. Let me know if my voice is audible clearly and the blackboard is visible clearly. Yes, good evening, Tishmodi. Okay, unit test from third. So, okay, from day after tomorrow, you have your unit test, is it? Okay, cool, cool, cool. So, yeah, that's there. But so, since we have to complete the syllabus sooner, we are not going to cancel any of the classes. So, your classes will be continued as it is scheduled. Okay, your classes will happen without fail every day. So, yeah, guys, cool. So let's start our class with the problem solving. So yeah, I hope everyone have got this problem, the previous problem which is on your screen. I hope everyone have understood this problem. Yes, I'm going to end the poll, guys. Thank you. Yeah. So I hope this problem which is being displayed, a parallel plate capacitor with air filled between the plates has a capacitance of 8 picofarads. So what will be the capacitance if the distance between the plates is reduced by half? What was that? So we said if the distance is reduced by half, say this is the initial distance was D, then the capacitance initially was C, that is 8 picofarad. So when its distance is reduced by half, the capacitance increased by a factor of 2, right? So then the capacitance became 16 picofarad. When I inserted a dielectric medium of dielectric constant 6, this capacitance changed to 6 times of what it was in the second stage, say 6 into 16, that is 96 picofarads. So this was the problems which we solved in yesterday's class. I hope this was clear to everyone. So let's move on to the next problem. So the next problem was this I had displayed. Few of you had also answered this. So please let me know. I'm going to launch the poll. So yeah, if anyone requires the explanation of this question. So the question goes like this. Say if the capacitor, if I have a capacitor plate, so if nothing is filled between the plates of the capacitor, no dielectric medium, only air is present, then the capacitance is called C. Okay, if I have another, say if I have the same capacitor filled with the dielectric medium in this design, okay, slanted lines design. This capacitor dielectric constant will give the capacitance of 2C. Okay. Say if I fill the third type of dielectric medium, that is the horizontal lines, sorry, vertical lines, dielectric medium. If I fill this between the plates of capacitor, it will give me 3C. Then, then if I have such arrangement, then what will be the value of capacitance if I have all four of this, sorry, all three of this in this combination in between the plates of capacitor? If I have a capacitance of say 2C dielectric medium, C dielectric medium, 3C dielectric medium, and 2C dielectric medium. So in yesterday's class, I think I discussed the same with you guys. So it will be combination of four capacitors. Yes, you have to consider it as combination of four capacitance of equivalent capacitance, since the capacitance, I mean, since the area of cross section and distance between the plates are same, have to consider four capacitors of C, 2C, 3C, and 2C connected in this fashion. Please check what's the effective capacitance, guys. Please check what's the effective capacitance. Yes, guys, please try to stay active. Hariprasad, check your answer. Priyanka, correct answer. Dhanush, correct answer. So for people in Zoom, I'm going to launch the MCQ. Please answer in your MCQ. So Dhanush, correct answer. Others, please try to answer. Madhavi, correct answer. So yes, guys. So guys, this will be same as say four capacitors connected in this fashion. Say if I call this as A and this as B, what is the effective capacitance of these capacitor combinations? You have to solve only that. Ramakrishna Reddy, correct? So here, people at Zoom, please give reply. I mean, please answer in your polls or in your chat. I mean, please answer in your polls and then your chat. If you want confirmation of your answer, let me know in your chat box. Okay, others. So come on, guys. I'll give you maximum of 30 seconds more. This is very simple question. We have more questions to solve. Yes, exactly, Madhavi. Superb. Hmm. So yeah, I'll take black now. So this, if I want to calculate the effective capacitance, C effective. Say first I'll calculate these two capacitance. So that is 2C into 3C divided by 2C plus 3C. So these two are added since these two are in series, right? Series combination, and these two are also in series combination. So since these two connections are in parallel, so I can add these two series combination. So C into 2C by C plus 2C. Okay, if you solve this, you would get the answer, guys. So what's the answer? So C effective, if you try to solve that, C effective is equals to 2 into 3, 6C square divided by 5C plus 2C square by 3C. So from here C square and C cancels. So we get C effective as, take the LCM, 3 6 are 18 plus 2 5s are 10 divided by 5 3s are 15. So in numerator I have C as common. So this becomes out as C effective is equals to 10 plus 20, 10C plus 18C, that is 28C upon 15. So this is your option. Yeah, option. Which option is that? Option A. Option A is the right answer. Hope everyone have got this. Yes, Adarsh, correct answer. Krishmodi, correct answer. Bhargav, correct answer. So here, yes, I'm going to end the poll, guys. Please check. So most of you had given me the right answer. Cool. Hope this is understood by all. Yes, this is understood by all. Okay. Next, if you give confirmation, I can go to next question. Guys, please give the confirmation if you have understood this. Click on S. Um, People at Zoom, please click on S if you have understood this question. Any doubts, please ask me. Okay, next. So you have to click on S, guys. Please click on S so that I can get the confirmation that you have understood. Not move faster. Okay, so next question goes like this. So I have a figure which is showing, okay, a figure shows a parallel plate capacitor having square plate edges of edge A. So I have edge A and the plate separation distance is D. So this A is nothing but my area of cross section, and the distance, I mean, it's separated by a distance, I mean, the separation distance between these two plates is D. So the gap between these plates is filled with a dielectric medium of dielectric constant K, and it varies parallel to an edge as K is equal to K naught times of X. So how is my dielectric medium varying? So with length, my dielectric medium is varying with length as K naught plus Ax, where K naught and A are constant, and X is the distance from the left end. So if I consider this is the initial point, so at this point, what will be my distance? If I consider this is my origin, I'll consider this as 0. I'll consider this as 0 centimeters or 0 units, whatever. So if I go along in this direction about X units, okay, if I go along in this direction about X units, yeah, with X, if I consider this distance at this point, the length, total length is A, right? Here, the length, initial length is 0. At this point, the total length is A. So any point between these, say, can be X. So at this point, now what I have to find? What I have to find, what is the total capacitance over the entire region 0 to A. So what should I do in this regard? How can I approach? How can I calculate my capacitance? So what is the expression for capacitance, guys? What is the expression for capacitance I would get for parallel plate capacitor? Say these two are the parallel plates. These two are the parallel plates of my capacitor. So yes. So my capacitance C is epsilon naught A by D. With the presence of dielectric, what happens? What happens to the capacitance with dielectric? Yes, with a dielectric, I have to multiply a constant, a dielectric constant K. Yes. Now, since my K is varying as a function of K naught plus AX, I have to do what function? In from calculating the capacitance from length of 0 to length of A, what should I do? Yes, correct, Bhargav. I have to integrate the value of K. So what will be my function? Say if DC, if I consider any, so I hope most of you might have learned this in your math course, how to consider integration. If you have given such things, you have to consider a small strip, okay, of length dx. So let us consider a small strip of length dx. Now if I try to integrate this length or this strip of small dx from 0 to a, can I get the total capacitance? Yes. If I integrate this small strip from 0 to a, from length 0 to length a over this region, I'll get the total capacitance. Yes. So I'll write the equation of capacitance as dc is equals to K times of epsilon naught A by D into dx. Okay, so I'll write this as small a, since this is small a, area of cross section given is small a. K is equal, dc is equal to K times of epsilon naught A by D. So my difference, I mean D is D only, whereas my K is varying as a function of dx, so I have written dx. Okay, now if I integrate over the space 0 to a, try to integrate, guys. try to integrate. I think this was not the options for this question. So please try to integrate and find the capacitance. Hope everyone is doing that. If anyone have any difficulty in integration, please let me know. Hope everyone knows how to do integration, right? Guys, does everyone know to integrate, how to integrate? Okay, cool. Please do the integration. So when we are trying to do the integration from 0 to a, so if I integrate from 0 to a of this capacitance, I'll get the total capacitance. So integral of dc would be the final capacitance c, that is equals to, what are constants here, guys? What are my constants here? My epsilon naught is a constant, my total area of cross section is a constant, and the separation distance is also a constant. What is my only variable? My only variable is my dielectric constant k. Again, it's varying as function of k naught plus ax times of dx. Please try to integrate this function. Yes, cool guys, superb. So please try to integrate this function. You would get the answer. Okay, I'm waiting for an answer. Okay, so let's check that. So E is equals to epsilon naught a by d. So integral of k naught into dx. So what is the value? Guys, please reply. Help me solve this. Integral of 0 to a k naught into x. K naught into dx. So as far as I know, integral of some constant will be given with the constant multiplied by the variable. Am I correct? Am I correct here? Guys, please let me know. So k naught times of x will be my capacitance. Yes, plus here I have a. So constant a multiplied with x variable. So what should happen here? It should be x into x power n plus 1 by n plus 1, right? So here n is 1, 1 plus 1 is 2 divided by 2. So, and my variables are from 0 to a. Now if you try to substitute, yes, correct, cool guys. If you try to substitute, what will you get? What will you get? So yeah, we'll go to next page. Okay, so we get that c is equals to epsilon naught a by d into k naught of x plus, what was that, ax square by 2 whole power 0 to a. So if you try to simplify this, you'll get c is equal to epsilon naught a by d into k naught of a plus ax, a into x. In place of x, I am putting a square by 2 minus 0, right? So on further simplification, I'll get epsilon naught a by d. If I take a common, it will become a square. So how? It's again a, a into, I'm taking a common from these two, that I'll get k naught plus a square by 2. Now if I multiply this a with this, I'll get a square. So this is the expression for your capacitance. Okay, hope everyone have got this. Krishmodi, please check your answer again. Yeah, I have not further simplified. I think this much is enough. Okay, so this is the answer for your capacitance. Hope everyone have got this. Please click on it if you have got this, or if you want any steps to be repeated, please let me know. Guys, please respond. Otherwise, it would be very difficult for me to continue. Okay, cool. Thank you. Hope everyone have got this. YouTubers, please respond. Yes, cool. So next question goes like this. So I don't know how the previous questions. Okay. So yeah, Please try to solve this question, guys. So the area of a plate of the area of each plate of a parallel plate capacitor is 150 centimeter square. The distance between the plate is zero point 0.8 mm. It is charged to a potential difference of 1200 volts. What is given? So in first case, given is, say, the area of each of the plates. Area is 150 centimeter square. Okay, and the distance between the plates is 0 0.8 millimeters. So the charge potential V, it's charged to a potential of 1200 volts. What is the value of the energy stored? E is equals to what? So Dhanush, you should know, guys, you should know the value of epsilon naught. How much is epsilon naught, guys? Always your values such as epsilon naught, h cut, and h nu. So if you remember in Planck's, you have to remember 4 or 5 constants. It's Planck's constant and your epsilon naught value and your mu naught value. You have to know that. So your epsilon naught value is 8.854 into 10 power minus 12 farads per meter. Okay. Please try to calculate what is the energy stored. So we know he is equals to half CV square. So we have to find the value of C first. What is the value of C? Capacitance. C is equals to how much? So we know C is equals to epsilon naught A by D, right? Epsilon naught A by D. So that is 8.854 into 10 power minus 12 into A is 150 into 10 power minus 4 by 0.8 into 10 power minus 3. So I have converted all units into meters. Please check. Please check your answer. What is the capacitance value you get? So it's 8.854 into 150 gives me 1328. So 1328 into 10 power minus 16 divided by 0.8 into 10 power minus 3. So its value is 1660 into 10 power minus 16 plus 3 minus 13. So I'm gonna write this in next page. Okay, I don't have space. So what's my capacitance, guys? What's my capacitance I would get? What is the value of capacitance I would get? Please reply. Yes. I thought I have some area. Please excuse me for a while. I'll just try to clear some area for writing. So first step we'll try to find out what is my capacitance. C is equals to epsilon naught A by D. So that is 8.854 into 10 power minus 12 into A is 150 into 10 power minus 4 divided by 0.8 into 10 power minus 3. So this value was somewhere around 1660 into 10 power minus 13. So if I want to simplify this further, how much would be the value of capacitance? Yes, the value of capacitance would be 1.65 into 10 power minus 10, correct? So C is 1.66 into 10 power minus 10 farads. So now if you want to calculate the energy stored, so guys, energy stored E is equals to half C V square. So E is equals to 1.6 into 10 power minus 10 into 1200 whole square by 2. So this is 1.66 into 1.66. So you'll get somewhere around 115 right? If I'm not wrong, you would get the answer as 115. So yeah, so your value is somewhere around 1.2 into 10 power minus 4 joules. Energy stored should be 1.18. Yes, you'll get somewhere around 1.18 into 10 power minus 4 joules. So that would be 1.2. Okay, so hope approximately this is the approximation value. Exact value you would get as 1.18 into 10 power minus 4 joules. Yes, everyone, I hope most of you have got this. Yes, please try to round off. Okay, if you have, some might have also got 1.15. If you try to round off, it would be 1.2. So please round off, it would be 1.2 into 10 power minus 4 joules. Okay, hope this is understood, guys. Yes, please click on yes if you have got this. We can go to next problem. Yes, any doubts in this, guys? If any doubts, please let me know. Prajwal, Prakash. Yes, Prajwal, correct. Prajwal, please check with your powers, okay? Prajwal EM, powers notpodi. Ramakrishna Reddy, correct. Madhavi, correct. And who else? So, yeah. Cool, guys. So, I hope this is understood, guys. Please give confirmation. So, energy stored is 1.2 joules. 1.2 into 10 power minus 4 joules. Any clarifications required anywhere, guys? Please let me know. Any clarifications required at any point? Please let me know. So the value is 1.66 into 10 power 1200 square. So you'll get 2390400 divided by 2. That is 1.9 or 1.18. So 1.18, it's around off to 1.2. Okay. Yeah, 1.1952 into 10 power minus 4, correct, Krishnaji. So we have rounded off that to 1.2, since 1.18 is nearly 1.2. Okay, cool, guys. Next question. So please try to solve for second one. So first one we had done. Please try to solve for second part. So the second part goes like, what is the capacitance of the capacitor when filled with a dielectric constant C? Sorry, constant 3. So we know the capacitance. What was the capacitance, guys? What was the capacitance we found in the previous case? It was 1.66 into 10 power minus 10 farads. So what is the capacitance now? C nu with the dielectric medium will be equals to 3 times of, yes, 1.66 into 10 power minus 10 farads. How much is this? Yes. So 1.66 into 3, that is 4 point. So my new capacitance is 4.98 into 10 power minus 10 farads. Okay. So this is my capacitance of capacitor when we are filled with the dielectric medium. Yes, correct, Prakash Kauda, superb. So others, guys, please try to check. Yes, Bhargav, correct. Ramakrishna Reddy, correct. Krish Modi, correct. Others, guys, please respond. If you have got this, please click on S. Zoom audience, please click on S. People at Zoom, please click on S if you have got this, or if you have any doubts, please ask. Okay. So next we'll go to next question. If you have got this, the third part. Those who have completed first and second part can go to the third part. So we have done this. Then the third part says, what is the energy? So, and when filled with this dielectric, what will happen to the energy stored? So we had studied in our previous class, the energy stored increases when an capacitor has some initial energy stored. When we introduce a dielectric in that dielectric medium in that capacitor, the capacitance increases by K, and also my current. So for the same amount of voltage, for the same power source, since my battery is not removed, guys, here it is very important. Since my battery is not removed, my energy stored also increases by a factor of K. So what will be my energy stored? So initial energy was 1.2 into 10 power minus 4 joules. How much is your final energy? U final. How much is your U final? Yes, correct, Prakash Koda. Please try to give the magnitude. So number Kodi, please give me a number as an answer. Please, everyone else, please try to answer, guys. I see very less response. So what is my final energy stored? That will be 3 into 1.2 into 10 power minus 4 joules. So 3.6 into 10 power minus 4 joules is my final energy stored inside the capacitor, right? So Bhargav, please check your answer. Okay, Bhargav is correct. Ramakrishna Reddy, check your answer. Hari Prasad, that's answer for second question, is it? Or third question? Please check your answer, Hari Prasad. Okay. So the final answer is 3.6 into 10 power minus 4 joules. Okay, guys, cool, superb. So everyone might have got this. Yes. Hope this was simple for you guys. I guess yes, it is. Is it simple or are you feeling difficult? Okay, so we have the last question for this chapter. That is, find the equivalent capacitance of this arrangement shown in the figure. If A is the area of each plate, so if A is the area of each plate is, so if A is the area of each plate, so this entire plate, guys, so this entire plate area is A. Area of cross section of this entire plate is A. So there are two plates of same area of cross section A. So what can we say about the area of this K1, K2 and K3 and K1? Is it exactly half? Is it exactly half? What do you say about area here? What is this area, this small area? So if you see here very carefully, this area is exactly half of its total area. So yes, please take this as half. If this is A by 2, this also will be A by 2. Okay, if this is A by 2, then this also will be A by 2. Please try to calculate what will be the capacitance. Say your capacitance, equivalent capacitance would be something like this. Please try to check out, guys. Hope you guys are solving along with me. So have two capacitors connected in series, right? And one capacitor connected in parallel. Say if this is K1, this is K2 and K3. So capacitance C1, C2 and C3, right? With each area of A by 2. The capacitor K1 has a separation distance of D, whereas capacitor C2 and C3 have a distance separation of D by 2 and area of cross section A by 2. So if this is the nature of the circuit, please find out what is the effective capacitance. So guys, how to approach this? First try to find out the individual capacitance. What is my C1, guys? What is my C1? Yes, Dhanush, super Dhanush, cool. So K1 by 2 plus K1, K2. Dhanush, check ಮಾಡಿ ಒಮ್ಮೆ answer. Please try to check the answer again. So, yep. So K2 and K3 in series and K1 in parallel to them, correct, Hari Prasad. So C1 is epsilon naught A by 2 by D. So K1 times of epsilon naught A1, C1 is K1 times epsilon naught A by 2 by D. So this will be, yes, correct, Krish. Sorry, correct, Dhanush. Super. So my C1 would be K1 epsilon naught A by 2D. So this is my C1. Similarly, what is my C2? Guys, C2, if you see, it's nothing but K2 into epsilon naught A by 2 D by 2. So from here 2 cancels. So my final expression would be K2 epsilon naught A by D. Similarly, C3 will be K3 epsilon naught A by 2 D by 2. So 2 cancels. Again here I'll get K3 epsilon naught A by D. So these are my capacitance of C1, C2, C3. If you try to plug in the values, you would get the expression as, guys, you should be practicing these problems of equivalent capacitance in such a way that on looking at the circuit only, you should write down the expressions. Okay, it should be that level of yeah, you should be in that, you should practice to that level. So as soon as you see the circuit, you should write the capacitance, effective capacitance, without writing intermediate steps. Okay, you have to practice to that extent. So what is the C effective, guys? Please check, please tell me what is the C effective. Hari Prasad, no, please check your answer. There is one small change. See, in K2 and K3, I mean in capacitor C2 and C3, there is no denominator, there is no change in denominator, whereas in K1 there is small change in denominator. So my final capacitance, so I have to find the value of series capacitance. So these two are connected in series. I can call it as K2 C. So if I call C is equals to epsilon naught A by D, then K2C into K3C divided by K2C plus K3C plus C1. So C effective will be C1 plus K2C into K3C by K2C plus K3C. So this will be, what is my C1 value? K1 by 2 epsilon naught, or K1 by 2 into C plus K2 K3 C square by K2 plus K3 into C. From here, get my expression as C effective. So what will be my C effective? C effective is equals to K1 by 2 plus K2 K3 by K2 plus K3 into epsilon naught A by D. So this is my final capacitance. Okay. So this is the effective capacitance of the capacitors connected in this final answer. So this is the final answer, guys. Hope this is understood. Yes, guys. So this ends your capacitance chapter. So these were few problems you had to practice. So other than these, there are few sets of problems which ask about the circuits, heat produced, etc. So those problems will be solved in our next chapter. So here in this chapter, we have solved minimal number of questions regarding capacitor, because we will be solving more number of questions in our third chapter, that is current electricity, where we will be getting more different sets of questions, where like capacitors connected in the form of Wheatstone bridge, RC circuits, etc. So we'll be discussing in the next chapter. Okay. So in C2 and C3, area will not be divided by 4. No. So yes, Madhavi, please check again. Madhavi, hope you are following. So here, what's happening? So if you try to simplify the statement, I mean, if you try to simplify the capacitance, my 2 and 2 values gets cancelled out. Okay. Madhavi Kundrapu. So yeah, if you try to simplify, if you try to check this 2 goes to numerator and this 2 is remains in denominator. So the both the 2's gets cancelled. Yes. So guys, yeah, this is much of capacitance. So we'll go with quickly jump on to the next chapter. So that is current and electricity. Okay. So any doubts in this chapter, guys? Any doubts? Any doubts in this chapter so far? So we learned about the capacitance of a capacitor, general capacitance. So C is equals Q by V. Then we talked about the capacitance of a parallel plate capacitor. So yeah, we'll make a note of that, right? So initially we started with the capacitance. The general expression is Q by V. For given amount of charge, there exists some potential. So the capacitance is given by Q by V. The SI unit was Farad. Farad was very large unit. So we try to write the okay, we try to write the SI unit in terms of microfarads, nanofarads, millifarads, etc. So it's very huge quantity. Then we check the capacitance of a parallel plate capacitor. It depends. Okay, we checked for the capacitance of a spherical conductor. So for a single conductor, the capacitance was 4 pi epsilon naught R. So then for the earth size conductor, we wanted the capacitance to be of some radius. Say for using this expression, if capacitance was to be 1 farad, the radius was supposed to be somewhere around 9 into 10 power 9 meters, which is some 10 power 4 times, 10,000 times greater than that of earth size, which was not possible for us. So if we have to increase the capacitance, we have to introduce two capacitors. So again, one more thing which we come to know from with this capacitor equations is the capacitance depends only on geometrical properties. Okay, only on geometrical properties. Yes. Then we derived an expression for two conductors. Say if we have two conductors charged with opposite polarities or opposite charges, then the effective capacitance is given as C is equal to Q by VA minus VB. With this, we check that the capacitance of this capacitor increased. As my potential decreased, the capacitance increases. So then we started with the capacitance of a parallel plate capacitor. So the capacitance of parallel plate capacitor is given by epsilon naught A by D. So where even here the capacitance depends only on the area of cross section and distance between the plates. Then we studied the various factors in which the capacitance of my capacitor depends. So one such factor is, say, if I increase the area, the capacitance increases. If I decrease the area, if I decrease the separation distance, the capacitor increases. Then we started with something called as dielectrics. So all dielectrics are insulators. Dielectrics are nothing but insulators, right? So all dielectrics are insulators. They don't have free electrons for conduction of charges. No free electrons. So yeah, whenever an dielectric is placed inside a uniform electric field, dipole moment exists. A dipole moment exists. See, there are two types of dielectrics. So one is polar dielectrics, other is non-polar dielectrics. For non-polar dielectrics, what happens? The molecules elongate a bit and the polarization occurs. Say for polar or molecules, the dipoles just are all inherently present, but they align themselves in the direction of electric field. So these such non-polar dielectrics which align, which form the polarization, such dielectrics are called as linear isotropic dielectrics. So for this dielectrics, the polarization was given by a vector that is nothing but dipole net dipole moment by volume. So this was for any other case. Then this was the polarization can be quantified for such dielectric mediums. And yeah, there were formation of boundary charges in these conditions. In the case of non-polar dielectrics, there were formation of boundary charges in the bulk of any, except the boundary. If we consider any point, any region in between the plates or in between the dielectric medium, the net electric field was zero. Sorry, net charges were zero. Then for this, the polarization for linear isotropic dielectrics were also given by P is equals to chi times of epsilon naught into electric field. So this was the other expression. Then we calculated the polarization vector. The magnitude of polarization vector was nothing but the sigma p, that is the surface charge density of these uh, boundary charges. Yes, then we calculated for the how my capacitance. So how the capacitance of the capacitor increases in the cases where yes, again we had few cases where we had discussed about how the capacitance increases when my dielectrics introduced into parallel plate capacitor. And yeah, we solved few problems, and this is the end of our capacitance, guys. Cool. So next we'll be starting with the next chapter, that is current electricity. Hope everyone is have come prepared to this chapter, guys. Are you guys ready? Shall we start this chapter now? So, I guess we'll just give you a quick briefing about current electricity. So, guys, what do you mean by current? So, for this chapter, I need lots of your support, and please give reply as when required. Please let me know what you mean by current, guys. So, is current an electrical word? Did we know about current inherently? Like, did we know what a current is? So why do we have to study this chapter, current electricity? So what is a current then? Yes. So yeah, correct, guys. Superb, awesome, Prajwal, Madhavi, Priyanka, Bhargav. Super, guys. So yeah, the current means, okay, actually in actual, current is derived from mechanics, not from electronics. It's from mechanics. So it's the branch of physics which deals with motion of objects, right? Mechanics. So current was initially derived from mechanics. So this was they knew current as water current. So when did we started to realize there are presence of electrons, there are charges which are moving, etc. So it was in the 1700s, say 1720s, when Michael Faraday. So when Michael Faraday, so there were many other scientists who were also, working on current and electricity. Now, what makes Michael Faraday so great? So I hope most of you might have learned what Michael Faraday had given, the Faraday's law, right? Hope most of you have seen that Faraday's law. So there was Michael Faraday, there was Christian Oersted. So these people, they were working somewhere around this time, 1700s. So they were all working on something called as electric current. So they didn't know what electric current is. Actually, at this time, we didn't know what electric current is. But though we know there existed charge, there existed current, okay, there existed everything, but they didn't name it. So they saw that there were some tiny particles which were moving inside any conductor. Say if I take a metal piece, they said some tiny particles moved. So when I apply some energy, some amount of energy to this, some tiny particles moved inside the conductor. So they didn't know what is the tiny particle. So they called it as quarks. Again, so quarks is not here. So inside a quark, there was some small particle which was moving, so they called it as, yeah, they didn't know what to call it as, so they called it as current. So instead of calling only current, they called it as electric current. So Michael Faraday, will be studying about Michael Faraday's experiment and Christian Oersted's experiment. Maybe by now you might have studied in your 10th standard about the current, the Oersted's experiment and Faraday's experiment. We'll again study all those experiment in magnetism, but before that we'll study about what is current. So yeah, as many of you said, current is nothing but, here it refers to electric current, that is nothing but flow of charges. Okay, yes, this is the flow of charges, correct. So in today's class we'll study about introduction, just basic introduction of what it is. So have you seen this, guys? Have you seen this? So we discussed about this. What are this? Yeah, what are these actually? Yes, we have seen this. Yes, what is this? Yeah, we have seen this. We know it as lightning. So is lightning a current? Is lightning a current? In our previous class also, or in our previous chapters also we had studied. So is lightning a current? Is it electric current? So I'll keep it as electric current only. Is it an electric current? Yes. Yes, this is a lightning. The lightning is an electric current. We had discussed this. We had discussed about this in detail in our first two chapters. So there were clouds. So these clouds come and collide with each other, and they rub. So there was formation of negative charges on the bottom surface of clouds and positive charges on the upper surface of clouds. So these negative charges, when the charge density increased, so these charges try to discharge through air, breaking the air. There was air breakdown, right? In yesterday's class, we discussed about air breakdown. So when charges are being discharged, I told you, right, in yesterday's class. So when charges try to discharge, they heat up the air here, and there is high voltage produced, high voltage of charges produced. These charges, what will they do, guys? What will these charges do? Yesterday, I tried to explain what does these charges do. They just ionize the air, right? So they just ionize the air. So what happens? The ionized air creates the positive and negative charges, the plasma. We could call it as the plasma state, right? So there was a plasma state created, and this there was air. The breakdown of air happened, and that discharge of air, I mean that discharge of entire amount of lightning or entire amount of charges as a strike of light or as a strike of lightning happened. So yes, then from there we get the light. Okay, so because of charge disruption, there is production of light. So guys, how many of you? Okay, that will come in our next part. So have you used this? I mean, what's happening here? So I hope most of you might have used this. Most of you know this. So what's happening here? What? Please give a small description. Like, yeah, I'm touching a light button. I mean, I'm touching a button and the light is turning on. So what actually is happening here? What do you think actually is happening here? Yes, it's on and off switch. So my switch is turning on and off continuously. But when it's turning on, what's exactly happening inside this? What do you think exactly is happening? Yes, correct, Prajwal. So when I turn on this switch, so there will be some presence of battery inside this. So most of you might have seen, yeah, there is a battery which might be connected to a bulb. Okay, so and its switch is connected here. So whenever I touch this, the switch turns on and this bulb starts to glow, right? So this is a simple circuit. So here, whenever I touch the switch, what's happening? What is happening? Yes, correct, Prajwal. So whenever I touch the switch, the circuit is completed and some charges are being flown. Yes, when switch is on, electron starts to flow. Okay, yeah. So yeah, on touching the circuit, it will complete, and the charges which are, say, I have in this chapter we'll be discussing about the positive charges as well as the negative charges. Okay, the negative charges will flow from here to here, and so the amount of current will be same, and we'll study about that in detail. Okay, so yes, whenever I touch the light bulb or whenever I touch the switch, there is some flow of electrons from one end. So there is some flow of electrons from one end to other end. So there is some flow of current, and flow of electrons is will be in opposite. We'll study about that in detail. So how much amount of charges move out? same amount of charges should also enter. So guys, this is very important for us in electricity chapter. It is the very important thing. How much, so the amount of charges or the number of charges which are being going out, or the amount of charges is always conserved. Okay, so amount of charges which are leaving the circuit, so are leaving the battery, the same amount of charges should also enter the battery. So sir, then if same amount of charges is leaving and entering, what's the use of battery? Guys, what's the use of battery then? So my battery provides the required force only. Okay, so next, have you seen this? Guys, what all do you see here in this? Please take, yeah, cool. So please let me know what all do you see here in this. Have you seen this? What do you think this is? Okay, you see 870 watt. Nice. So Rakesh spotted this. There is something called as 870 watts. Okay. Others, please try to answer. Guys, come on, try to participate in the class. Okay. Okay, Priyanka says it's a laptop. No, it's not a laptop. It's a laptop charger. Actually, it's a laptop charger. So, okay, Prajwal says he sees the cautions. Okay, I mark the cautions. So Prajwal sees the cautions. Others, guys. Okay, Hari Prasad sees the QR code. Okay, we see the QR code. So guys, we don't want to deviate from our studies regarding this chapter. So like Rakesh said, he saw 870 watts, right? Regarding this chapter, what do you see regarding current electricity? What are the things which you see? Yes, maximum power output is 8. So who sees this? Kashmuri says this charger consumes some power and delivers some power. So maximum power output is 8 amperes. Okay, cool. So someone says Hari Prasad says he sees 12 amperes battery. Okay, maximum AC current it can withstand is 12 amperes. Any others, guys? Any other thing? Okay. So Dhanush says we see the power. Okay, we have marked the power already. Anything else other than power? Yes. Anything else, guys? So what do you think this AC is? What is AC? And what do you think this strange symbol is? You know what is this strange symbol? Anyone knows what is this symbol? This one here. What is this? So what is the strange symbol? Have you seen this? Okay, I'll ask doubts. So I don't know what is this strange symbol. Please help me understand. Then I also don't know what is this 50 and 60 hertz. You know what is this 50 and 60 hertz mean? Yeah, why is it given 100 volts to 240 volts? And what does this mean? And yeah, really. So yeah, most of you might have seen this. Okay, not visible clearly. Please try to zoom it, guys. You can zoom it. I think you can try to zoom your screen, pinch your screen so that it can get zoomed. Yes. So Prajwal, okay, cool. So this symbol means direct current. Okay, this symbol means direct current only. So direct DC to DC conversion. Okay, it's DC to DC, not DC to AC. It's direct to direct conversion. So it's converted from 17 amperes to 1.5 amperes. So yep. So here my output is of two types. One is 71 ampere, 12 volts, 71 amperes. So I don't want 12 volts, 71 amperes. So I'll be using 12 volts stabilized voltage with 1.5 amperes. So this is DC-DC conversion. So, and one more, yes, correct, Bhargav. So this is 50 or 60 hertz. I can apply this, I can use this same laptop charger for wherever I have a power supply of 50 hertz or 60 hertz. So we'll learn what is 50 hertz, what is 60 hertz. So most of you might have seen this. So you guys saw this power rating. So this is nothing but the power ratings. So this is yeah, this is again your maximum power. So this is your current ratings, current ratings. So did you see voltage anywhere? Yes, this is my voltage ratings. So voltage required. So this is my output voltage and output current, output voltage and current ratings. So these are the things which we see. Now tell me, what is an voltage? Voltage, and what is my voltage? What is my current? So I hope most of you might, yeah, have seen this. So I think most of you know what is this. So what is this, guys? What is this again? This is, what do you call this? Is this a cell or a battery? Yes, correct, Bhargav. How many number of times my current changes its direction is, yeah. Okay, what should I call this? Is this a cell or a battery? Is this a cell or a battery? Okay, it's a cell. Okay, when can I call it a battery then? What is the difference between cell and a battery? What is a battery then? Okay, if you say this is a cell, what is a battery then? So if you say this is one cell, right? This is a cell, correct? Yes, exactly, Hari Prasad. So this is a cell. If I have n number of such cell connected, then this becomes a battery. So yeah, most of you might have seen this. Yeah, we have 1.5 volts. So what do you mean by 1.5 volts? So guys, I'm very enthusiastic. Like I'm curious to know what what is 1.5 volts mean. Why should I write 1.5 volts? So what do you mean by 1.5 volts here? Yes, correct, Prajwal. Correct, Bhargav. What is 1.5 volts now? So I don't know why. Why should they call 1.5 volts only exactly 1.5 volts or something like that? Why can't they call anything else? So why is it only 1.5 volts? Or what is 1.5 volts here? So 1.5 volts is the voltage produced by cell. This is what Hariprasad say. But how will it produce? So will it produce positive charges or negative charges? Now, yeah, you guys are telling yes, it produces 1.5 volts of charge. Okay. So what is this 1.5 volts? And if it's producing any charge, which type of charge is it producing? Yes. Okay. Priyanka says potential, it's capable voltage. Okay. So when okay, this is called as potential. So potential, guys, what we learned as potential in our previous class. So potential was nothing but total amount of potential energy per unit charge, right? Potential energy per unit charge was potential. Is this the same potential? Okay, correct, Bhargav. Cool. So Bhargav says it will not produce charge, but it will direct the charge, right? So guys, yep. So let me give some clarifications, guys. This is not potential alone. It's called as the potential difference. Okay. So please note that this is not only potential, it's potential difference. Always, whenever you say for a battery or a cell, you have to say it as potential difference. It means the difference between this and this region. Say if this is considered to be a positive region, I mean positive electrode, and if this is the negative electrode, the if we connect this across a measuring device, say voltmeter, how much difference is present? how much potential difference is present between the positive lead and negative lead. This is called as the potential difference. Okay, it always measures potential difference, not potential difference. So by convention, we assume this is maintained at a higher potential. The positive is always maintained at a higher potential, and negative will be always maintained at lower potential. Okay, yes. So since this is converting, so this is converting chemical energy. Chemical energy is converted to electrical energy, right? Chemical to electrical. So such type of conversion, it's always called as EMF. So it's not EMF, electromotive force. It's not that, as most of you know, it's that your teachers might have told you it's the force which moves the electrons. Yes, it's true one way, but technically we should not call EMF as force which moves the electrons. No, EMF is anything where the conversion of one form of energy to other form. When we convert one form of energy to other form of energy, we call that forms of conversion as electromotive force. Okay, so again, yeah, but for your knowledge for now, you can just believe that it's a force which moves the electrons. Okay, so when we connect a voltmeter to this, it will just measure the difference in potential. Say at higher potential, I might be having 1.5 volts. At lower potential, I'll be having 0 volts. Okay, so if I check this, if I connect this with a ground, then I can see there is a difference in potential. That difference in potential is the potential difference which is mentioned here. So next time, please don't say it's potential and all, it's potential difference. So can you see this? Okay, this highlighted structure in bulb. Have you seen this? Yes, exactly, Priyanka. So what do you see here? So this sees the power rating. Okay, this again gives the power rating. It means how much power my how much power this device consumes. Okay, it just says how much power this device consumes. Okay, this is device consuming. Okay, next classes we'll be seeing about how the capacitors and inductors, how they behave. So let's have a recall test on this chapter. Please take the recall test, guys. I have launched a poll for recall tests. There are 5 questions. One question is in the next page. Please take the recall test. So guys, the first question goes like this. The current is said to be in the direction of motion of. So let me see how many of you would answer correctly. So the current is said to be in the direction of motion of. So next, yes, they also mentioned that. Cool. So when no electric field exists inside a conductor, the free electrons. So please answer question number with answer. Okay. Always, guys, please try to answer with question number and answer. Zoom audience, please answer in the polls. YouTubers, you could answer with question number and answer. Please try to answer all 5 questions together. Okay. Please answer all 5 questions together with question number. So second question goes like, when no electric field exists between or inside a conductor, the free electrons, what happens to the free electrons? Then third question goes like, the force on the electron in an electric field is in the direction, which direction is my field? So fourth and fifth question are the questions from previous chapter. The capacitance C of a capacitor is. Okay, hope everyone have completed first 4 questions. So yes, I hope everyone have completed first 4 questions. If anyone requires any previous questions, please let me know. So this is the fifth question. The energy stored in a capacitor is in the form of. So Hari Prasad had given me the answer. Hari Prasad, please give the fifth answer too. So others guys, please try to answer. Please try to respond. Okay. Others guys, please try to give the answer. Hope students in Zoom have also provided the answer. Yes. Okay, cool. Guys, if you want me to show the previous questions, please let me know in the chat box so that I can answer. So please remember the fifth question, okay? So the energy stored in the capacitor is in the form of option A, potential energy, option B, kinetic energy, option C, elastic energy, option D, magnetic energy. So I'm reverting back to the previous screen. So hope everyone have answered. So I received only 7 responses out of 16 plus students. Please reply guys, others please try to respond. Okay, I'll wait for 30 seconds more. Let's see how many of you got 5 out of 5. So I'm going to end the poll guys, cool. So most of you have answered for option for first question. So yes, I'm sharing the results with you. So most of you answered option B for first question. Yes, the current is said to be in the direction of the motion of positive charges. Option B is the correct answer. Okay. Second question, when no electric field exists between inside a conductor, the free electrons, yes, they don't stay at rest. So the second question, most of you are given moves with a constant velocity. So is it constant velocity or constant speed? Yes, guys, it should move with a constant velocity. So, yep. Okay, this is not stays at rest. So it moves with a constant velocity. So because of the thermal charges, okay. So because of at room temperature, when no electric field exists between inside a conductor, the free electrons will be at room temperature. At room temperature, there will be some presence of thermal electrons, which will be having some mobility. Okay. Next, third question goes like, the force on the electron in an electric field is in the direction of opposite to the direction of electric field. Okay. So fourth question, the capacitance C of a capacitor is independent of charge and potential of the capacitor, dependent of the charge and independent of potential. Okay. Yes, my capacitor always depends only on the geometrical configuration, so it's independent of what? It's dependent on the geometrical configuration of conductor. Okay. So yes, next the fifth. Okay, yes, Audhubarga, no, there won't be any force. Yes, fifth question is like the energy stored in capacitors in the form of potential energy. Okay, that is true. Sorry. Cool, guys. So I have ended the poll, and yeah, we have discussed. So now we'll come to the definition of current. So definition of current electricity, it is the continuous flow of electrons in a circuit. So when we have to discuss about the current electricity, it's about the continuous flow of electrons in a circuit. So guys, we'll start this chapter fresh from tomorrow. I think that would be good. So we don't have to rush the chapter as it is. So if we try to rush, then everything would go in vain, right? So in next class, please come prepared with the structure and yep, how the current happens, how current exists between the plates of conductor on yeah in a conductor when we apply potential, how my current exists. So what are the SI unit of current? Then yeah, we'll also discuss about few problems on how my current exists and yeah, other forms. Cool, guys. So prepare well for your tests. I don't know whether your tests. I mean, is the test cancellation? Or, I don't think cancellation of classes is possible for any of you guys. No, it's not possible. All of you must attend all the classes. So you have, as we talk with your principal says they have tests only till afternoon. So they might be in a they will be in a position to attend classes in evening. So no need of canceling any classes. This was the reply from your teachers and principal. So I think there won't be any cancellation of classes for you guys. So you have to attend all the classes. Okay. So then how can we say direction of current is along direction of flow of positive charges? Yeah, Bhargav, we'll discuss about that in tomorrow's class. Okay. So we'll discuss how the current flows in the so how the direction of current is only in the positive direction, and we'll check uh, all of it in next class. Okay, guys, please take your NPS and if you have any doubts, any other doubts, please let me know. So current produces opposite to electrons flow. Okay. So Bhargav, to answer your question, say if I have any electric field. Okay, so I think we discuss about that here. So we have a conductor. So all the positive charges in the presence of electric field, they go in the direction of the electric field. So what happens to the electrons then? So my electric field is because of these positively charged particles. Now, if my electric field exists in this direction, yes, obviously my electrons will be attracted towards the positive charges, right? So my positive charges are always being repelled from the plates of positive plates. So and is attracted towards negative plate. And yeah, my electrons or negative charges are being attracted towards a positive plate. I think this is how the direction of current occurs, where the direction of current is considered as positive charges, flow of, of positive charges, and whereas direction of electrons is opposite to the direction of flow of positive charges. Okay. So this is much of it, guys. Please come prepared to the to your next class so that we can start properly again. And yep. So for everyone who is attending test from tomorrow, all the best, guys. If anyone is attending tests, do you have tests tomorrow? I don't know whether. If there, let me know. And if you have any doubts in physics, class 12th physics, any chapter, you could also contact me anytime in my WhatsApp number. Okay. Okay, guys. Okay, guys. Please give your NPS and you could leave the class. Thank you. Okay, cool. You have from day after tomorrow. Yeah, everyone having in different times schedule. Okay, cool, guys. Take care. People who are present in class, please take your please give your NPS and then leave. Thank you, guys. Okay, guys, cool. Okay, cool. See you guys. Bye.